All right, ladies and gentlemen, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom with me, Coach Guth. We're starting Unit 6 today, oh boy, right before Thanksgiving break. And Unit 6 is going to be half about parabolas and half about factoring. So for those who are good at factoring, that's good for you. But the first few days is going to be over parabolas, okay? So today is going to be over the focus and directrix of a vertical parabola. What a fancy word. So hopefully we'll be able to find the focus, focal length and width, and directrix of a vertical parabola by the end of today. Okay, so you guys know a parabola as the shape that a quadratic graph makes, right? When you see like y equals x squared or f of x equals x squared, you pretty much know parabola is the shape that it makes. It's that U shape. But actual definition, another definition for a parabola is that it is the set of all points that are the same distance from a fixed line and a fixed point that's not on the line. So what does that even mean? If you look at this picture, right? See this parabola right here? Yeah. This is my fixed line right here, and here's a fixed point. It's very specific depending on the parabola, okay? So every graph is different, but this is my fixed line, this is my fixed point for this parabola. This orange point, this green point, these are two random points that I just picked, okay? But notice, this orange point from my fixed point to this orange point and from my line to that orange point is the exact same distance. You see this? That's the exact same distance. Then this other random point right here. This one we can actually count. Look, 1, 2. And then also from the line, 1, 2. Every single point on this parabola, no matter where you pick, is going to be like that. Equal distance from the fixed line and equal distance from that point. So that's what a parabola actually is. Okay, so let's label for some new vocabulary. So first of all, we have the vertex. That's the same as always. You guys know where the vertex is. Which point right here, what color point is the vertex? Red. The red one, right. So you don't need to label that if you already know, but I'm just labeling it right there. And we already know the vertex is at the point h, comma, k, right? Okay? Now, the fixed point is called the focus of the parabola. Now, where do you think the fixed point is? The blue one, that's right. That is the focus. So that is going to be my focus. And the focus of the parabola is always at the point h, comma, k plus p. Notice the h and the k, right? That's just from your vertex, but now we're adding this p value to k for the y. Okay? Next up we have the fixed line. The fixed line is called the directrix of the parabola. Where do you think the fixed line is? The blue line, right? There's only one line here. That is the directrix. And the directrix always has the equation y equals k minus p. So that's the same k from the vertex, but now we're subtracting whatever the p is. And you might be wondering, well, what's p? And the next one tells us the distance between the focus and the vertex of the parabola is called the focal length, and that is p. So this distance right here between the blue and the red points, that is your p-value. And that is called the focal length. Okay, so just real quick, what is the focal length? What is p for this graph? 1, that's right. You can see it's just 1 unit. Now normally we always talk about length and positive, right? Because it's a length or whatever. But in this case, when we're talking about focal length, we can have positives and we can have negatives, because sometimes the focus is above the vertex, sometimes it's below the vertex. So we use the negative sign to differentiate whether we're going above or below the vertex. Okay? Also, the final thing then, the width of the parabola. The width of the parabola at the focus is called the focal width. So, how do you find that? You start from the focus, right? And you're just going to go left until you hit the parabola, go right until you hit the parabola. So, watch this. I'm going to start at my focus. I'm going to go left until I hit the parabola. Boom, stops right there, right? Then I'm going to go right until I hit the parabola. Boom, right there. From the focus, that length right there, that is the focal width. So what is the focal width of this graph? What's that total distance? 4. The focal width is 4. That's right. So you can see that the focal width is always equal to absolute value of 4 times p. And it's absolute value because you can't have a negative focal width because it's going both directions, right? It's not going to be a negative. It's just a solid distance value. Okay? So you can see that in a lot of these things like focus, directrix, focal length, focal width, you see a P in all of them, right? Yeah.
And what's the other line? The orange one?
That's just a demonstration to show you that it is indeed true that from your focus and from your directrix is always the same distance. Yeah. Okay, so how do we find P? Because you're not always going to have a graph that's simple, right? That one was obvious because it was right on the line, 1 unit. But you want to be able to find P from an equation. First, you got to remember the standard form of a quadratic graph is always y equals ax squared plus bx plus c. And the vertex form of a quadratic graph is y equals a times x minus h squared plus k, where hk is the vertex. Notice real quick, we didn't use f of x here, right? We said y. Because we're going to be working with things that are not functions here starting tomorrow. So we're using y instead of f of x here, okay? You have a question?
I got the rest.
Yeah, just get the pass. All right, so notice though in both of these equations, you can see the a, right? You see a in both of these? Well, through derivations, so people have already derived this, but a equals 1 over 4p. And you can use that information to find p every time from your equation. Okay? Okay, guys, so I want you to just get this in your head. A always equals 1 over 4p. All right? You guys remember that yet? A always equals 1 over 4p. It's 1 over 4p. All right, because that's going to be very important when we're finding p. So here we go. So for this example, we're going to find the p-value for the graph of y equals 1 over 4 times x plus 2 quantity squared minus 4. Remember, a always equals 1 over 4p. So we can use that to find our p-value. So step 1, we need to identify the a that they told us in the equation. What is the a value in this equation? 1/4, right. Because right here, that's 1/4. Okay, now, a always equals what?
1 over 4p.
1 over 4p. So we take whatever we saw in that first step, we saw, okay, a is 1 over 4. And set that equal to 1 over 4p. So we're going to write 1 over 4 equals 1 over 4p. And it's always going to be equals 1 over 4p. It's not 1 over 4p because I was 1 over 4 over here. That's just, by coincidence. You always set it equal to 1 over 4p, okay? So step 3, you're going to use cross multiplication to solve for p. So you have 1 over 4 equals 1 over 4p. So a blast from the past, we're going to cross multiply like this. And when I cross multiply, what would I get after I cross multiplied? 4 equals 4p, right. 4 equals 4p.
Then why did you put it versus step 1 a equals 1 over 4 1 over 4p?
Because a is 1 over 4, but a also always equals 1 over 4p.
Okay.
So that's why we're able to set 1 over 4 equals to 1 over 4p. Okay, we cross multiply and that gives us 4 equals 4p. So how do I find p then?
Divide by 4.
Divide by 4. And so p equals?
1.
That's right. And those are the steps. Just like that. So I want you guys to try those 2 examples. All right, let's check both of these and make sure we're not confused about anything here. So what is the a value on number 1? 1/8. And we always set it equal to what? 1 over 8 equals what?
1 over 4p. 1 over 4p.
1 over 4p, right. It's always equal to 1 over 4p. Then what do we do after this?
Cross multiply.
Cross multiply, and what does that give me?
8 over
8 equals? 4p, and then how do I find p?
8.
Divide by 4. You okay over there?
Yeah. P equals 2.
P equals 2, that's right. And that's this one. All right, the next one, number 2. What is the a value on this one? Negative 1 over 12. And we set that equal to? 1 over 4p, right. Always set it equal to that. Then what do we do? Cross multiply, which gives us?
12 equals 4p.
12 equals?
4p.
It's negative 4p, because it's negative 1 times 4p. And then what do I do to find p? Divide by negative 4, right? And so p equals? Negative 3, that's right. Negative 3. Good, so you know how to find p now, right? That's very important because you're going to be using that p-value in a lot of other things. So it's important that you know how to find it. So let's go to the back side then. On the back side, this is where we learn how to graph using the focus. We've already learned 2 different ways to graph, right? We had like the way where you had the table and you change the table values based on your transformations, right? And then we also had the estimating the graph from the vertex and the y-intercept and then reflecting the y-intercept. So now we're going to learn another way, and that's graphing using your focus. All right, because you see these numbers, look, y equals negative 1 over 4x squared, and then down here it's like y equals 1 over 12 times whatever. If you try to use those 5 basic points, you're going to see those 5 points will be very close together and very crunched down, and you're not really going to see a graph, right? It's going to be too small. But when you graph using the focus, you'll still be able to see a graph on these weird small parabolas. Okay, first of all, notice right here at the top, the focus, directrix, focal length, and focal width, all the formulas are given to you, right? That's how you find these things. And you can see we'll need to know h, k, and p in order to find all of these things, all right? So we're going to find the specified information for the following graphs. We're going to graph the focus and the directrix. Then we're going to graph the function using the vertex, the focus, and the focal width. So first, let's see what we can already identify. Y equals negative 1 over 4x squared. What is the vertex here? 0, 0, comma, it's not negative 1/4. Do you see the, do you see a plus k at the end?
No.
It's 0, 0, that's right. You don't see the minus h like after the x, right? You don't see anything in parentheses there, right? So that means the h value is 0. You don't see the plus or minus anything at the end, right? No. Which means the k value is 0, because you don't need to write those zeros in, right? That's just pointless. That's why you don't see it. So if you don't see it, the value is 0. That means your h is 0 and your k is good. So label that because you're going to be using those throughout all of these. Okay? We should be able to find the axis of symmetry right away. The axis of symmetry is going to be x equals 0, right? Because it is the h. X equals h is your axis of symmetry. Okay, and you cannot find any of those other things without finding p. So we need to find p first. How do we find p? A equals negative 1 over 4. Okay, and we set that equal to? Equals 1 over 4p, right. And then? Cross multiply, so that gives us? Equals? Equals 4. Divide by? So p equals? Negative 1, that's right. So now I have my h, I have my k, and I have my p. I can find everything else now by looking at those formulas up here. So starting with the focal length. What is the focal length? P, which is?
Negative 1.
So the focal length is negative 1. How do I find the focal width?
4p.
It's not just 4p. But what's on the outside of that 4p?
The absolute value.
Absolute value, right. Absolute value of 4 times p, and p is?
4.
Wait, p is?
1.
P. Negative 1, right. Okay, getting ahead of yourself there. But you're right. This absolute value of 4 times negative 1 comes out to be 4. That's right. And why is it not negative 4?
Because absolute value gives you positive.
Absolute value always gives you positive. Good. Okay, next we have to write the focus. The focus is a point. What is the focus?
H.
H. Okay, so what is h? 0. So the x value is 0, comma.
0.
What is the rest of it?
0 plus 1.
0 minus 1. That's right. Because you just take k and add it to the p, which is just like subtract. If you add negative 1, it's the same thing as subtracting. So it's k plus p, which should be 0 minus 1. And that means our focus ends up being what? What is the whole point? 0, negative 1. That's right. So the focus is at 0, negative 1. And then lastly, the directrix. What is the directrix? Y equals
K minus P.
K minus P. What's K?
The 0.
Minus
0.
minus negative 1. And so this equals what? What is 0 minus negative 1?
Negative 1.
It's positive 1. Because you see this minus the negative 1, that negative, if you think about it as distributing to this negative 1, that's like 0 plus 1 then. Okay, so let's graph it. First, we're going to graph the directrix. What is the directrix? Y equals 1. So that's this line right here, horizontal line through y at 1. That is y equals 1 right there. Okay, that's the directrix. Next, we're going to graph the vertex. Where's the vertex? 0, 0. And then we're going to graph the focus. Where's the focus?
0, negative 1.
0, negative 1 right there. Notice the focus and the directrix are always equal distance away from the vertex. One's just up and one's just down from the vertex. Okay? And then we need 2 more points though, right? You need 3 points so you can make that U-shaped parabola. How will we find our 2 more points? We're going to use the focus and the focal width. Our focal width here is 4, right? That means the width around my focus should be 4 total, right? So if I were going left and right, how many spaces should I go each direction? Each direction though. 2, because 2 to the right, 2 to the left, that adds up to 4. So like 1, 2, put a point there. 1, 2, put a point there. And you see, look, now the space, the distance between those 2 green points, right? That's 4. That's the focal width. Notice it's around the focus as well. Some people, put it around the vertex. It's not the vertex. It's called the focal width. So you go around the focus. And so there's your 3 points, and you can connect these. Boom. Boom, and there is your parabola. All right, so I want you guys to try the next one on your own. All right, let's look at example 2 together, make sure we all got the same thing here. First things first, we want to find out what we know. The vertex. What is the vertex on example 2 here? 1, wait. That's right, it's 1, negative 3. The 1 comes from the opposite of the inside. And then negative 3 comes right from the outside over here. So that means your H is 1. And your K is? That's right, good. You should also be able to write the axis of symmetry then. The axis of symmetry is? X equals 1, good. Okay, now to find everything else, you need to find P. So how do we find P? Okay, and then? Right? Cross multiply, which gives you? In the end it does, but after you cross multiply you get 4P equals 12, and then divide by 4, so P equals? Good. So now we have H, we have K, we have P, we can find everything. So what is the focal length here? 3. What is the focal width, or how do we find it?
4.
Absolute value?
Yeah, absolute value.
4 times 3?
Absolute value.
Because it's always 4 times your P, which is 3.
Equals 12.
That equals 12. So the focal width is 12. What is your focus then? Parentheses? 1. And where did that 1 come from?
The vertex.
It's the H in the vertex, right? And then comma, what is the rest of it?
Negative 3
Negative 3?
plus 3.
Plus 3.
All right, negative 3, which is K, plus 3, which is P, because it's K plus P.
Parentheses.
That equals 0. Right? So,
1, 0.
Parentheses, 1,
right, so your focus ends up being 1, comma 0. That's right. If you would change colors, please. Thank you. All right, good. And then last, we got the directrix, which is going to be what? Y equals?
Oh, negative 3
Negative 3?
minus 3.
Minus 3, because it's K minus P. Negative 3 minus 3, which is equal to?
Negative 6.
Negative 6. All right, so first let's graph the directrix. Where's the directrix? Y equals Negative 6, so we graph that. Y equals negative 6, that's right there. Then let's graph the vertex. Where's the vertex?
1, negative 3.
1, negative 3 right here. And then we're going to graph the focus. Where's the focus?
1, comma 0.
1, comma 0 right there. Notice the directrix and the focus are, look, they're both 3 units away from the vertex, just in opposite directions. Okay? And the vertex and the focus should always lie on the axis of symmetry. Okay, then, how do I find my other 2 points?
Oh, you move over 12.
Not move over 12.
Divide 12.
Divide 12 by 2, and then, yeah, it's 6. So we're going to move over 6 from where? From the vertex? From the focus. Notice it's called the focal width. That means around the focus. So around the focus, you're going to move 6 in each direction. Look, 6 to the right. Look, watch this. 1, 2, 3, 4, 5, 6. Put a point there. Then to the left. 1, 2, 3, 4, 5, 6. Put a point here. Because now look at the total width now. What is that? That's 12. If I move 12 in one direction and then I move 12 in the other direction, that's 24, isn't it? So that's why you cut it in half. Yeah. Yeah. Okay, so there are my 3. There's my 3 points, my vertex and my 2. Those green points right there. Connect those, and that is your parabola right there. Boom. Like that. Okay. So be careful about the focal width, right? You only want to move half of the focal width in each direction around the focus, not the vertex. All right, last up for today then, writing the equation of a parabola given your vertex and a focus. So if they give you a vertex and the focus, you should be able to write the equation of the parabola. Now remember, we're using y equals, right? Because we might not be dealing with functions here. Okay, but if they give you a vertex, what form do you think your equation should be in? Vertex form, right. Remember, vertex form is going to be y equals, do you know what comes after that? A times x minus h squared, good. Plus k, nice. There we go. Okay, now remember, they're giving you the vertex, so what do you already know in there? H and k, so what do you need to find? A. You need to find A. But, now Ronnie, you're right though, because we can't find A unless we have P. Because remember, A equals 1 over 4P. So if we find P, then we'll be able to find A. So this is what we can do. So step 1. Look right here. What is the equation of the parabola with the vertex at the origin and the focus at 0, 2? So we're going to label the vertex and the origin. So vertex, I said origin, didn't I? I meant focus. We're going to label the vertex and the focus. If the vertex is the origin, what are my point values? 0, 0. Which means my h is
0
and k is
0.
Good. Make sure you label that because you're going to be using this throughout, okay? Then your focus was 0, 2. But remember, the x value of the focus is also what? H. And what is the second value? It's not k. Look up at the top of the paper. At the k plus p. Let's straight out the top of the paper. You see that? H comma k plus p. Look right up here. Focus is h comma k plus p. They gave us the numbers, but if we didn't have the numbers, that's how we would find it, k plus p, right? So in step 2 then, because we know this number right here, 2, equals k plus p, we're going to write that. 2 equals k plus p. Okay, we write 2 equals k plus p, and like Ronnie was saying earlier, we want to find p, so that's what we're going to do right here. We're going to solve for p. How do you think we can solve from P from that step right there? Because we have all the information we need already. 2 equals K plus B. How can I find P? How can I solve for P? What?
Subtract K
But what is k? Like, because what's the point of subtracting k when I don't know what k is? K is 0. That's right. You actually already have k. That's why you labeled the vertex h and k. So we can replace the k with 0. So this becomes 2 equals 0 plus p, which means p equals? That's right. And obviously, you know, you might actually have to subtract it over if k was a number, right? But in this case, it's very simple. So p is 2. Good. So now that we know p is 2, we can find a. How do we find a? By plugging in p to what? 1 over? Right, because a is always 1 over 4p. We just found p, so 1 over 4 times 2. Which means that our a value is what? 1 over 8. So 1 over 8 equals a. So now you see we have a, we have h, we have k. We can write our equation. So what is your equation going to be? Start from the very beginning. It's an equation. Y equals 1/8. Parentheses. X minus 0, right?
Parentheses squared plus 0.
That's right. Parentheses squared plus 0. Okay, but we want to simplify this a little bit just because this looks a little messy. All the zeros are unnecessary. So if we took the zeros out, it would be y equals what? 1/8? X squared, just like that, yes. We do not need the parentheses because there's nothing inside the parentheses, right? It's just this is 0 there. And we don't need to write plus 0 at the end either. Your equation would look different if h and k were different numbers, right? If your vertex was different. But in this case, because the vertex is at the origin, your equation just ends up like that. Very clean, very tidy. But yeah, you can always follow this same process to find p, which gives you a, and then you can write your equation, okay? But that's going to end these notes. So I will see you in the next one. Peace!